Hi everyone. I hope all of you are doing good. It's been quite some time since we have connected. Actually, I was going through some other assignments, so there was this delay in uploading videos. I mean, the delay is about few months, right? But anyways, now that I'm back, I will try and I will definitely be regular this time. If not twice or thrice a week, then definitely at least once a week, I'll definitely upload a lesson and the lesson flow will continue as it was flowing before, right? Okay, so the topic that we have left off is on Python, and we were getting into Python for data analysis when I stopped making the videos. So we will start right from there. And the very first topic that we are going to learn today is NumPy. Now, what is NumPy? It's in the name itself. Num, numerical, Py, Python. So numerical Python. Okay. So all kind of numerical operations, be it simple, be it complex, like you can do with the help of the NumPy library. It works with arrays, it works with dimensional arrays, 2D arrays, 3D arrays, and all of these things, right? Anyways, when we are going to learn into with the help of coding, we will see more to it. So yeah, let's get right into it. Thank you. So here we are within the notebook. You can see this is Python NumPy as it is written. So just like any module, to install and import the library, we need to do two things, right? The very first thing is installation of the library. So the installation is something that you can do. Let me remove the terminal. Yeah, with the help of pip installer, right? So if you do pip install NumPy, it will install the same for you. It might take some time. So we can see that NumPy is already installed in my system. Okay, that's why we do not need to install it again if it is already installed in your system. Now, what is the next thing you can do? You can import the NumPy library. But before that, whenever you are working with a library, right, whether it's installed or not, how to check? You go to your terminal. Okay, let's say I'm in my terminal now. It will open up. Yeah, and let's say my virtual environment is also activated. Now what I'll say, I will simply do this pip list. Okay, so here if you go up, you will see NumPy is installed. 2.2.6 is the version that it has installed now. Okay, so if you do this pip list, you will see all the modules and the libraries that is installed in your system, installed in your environment. The exact word would be that. Okay, all right. Now the next thing to do is basically to get it imported. Okay, so what we will do, we will import NumPy as NP. NP is basically the alias that we use for NumPy. Okay, so if you simply run this, see it's already imported now in my particular notebook. So now what I can do, I can start working with the NumPy library itself. Okay, the very first thing that we are going to understand is array. Okay, so what basically is an array? Array is nothing but a collection of items, generally numbers, but anyways, array can be a combination of any items. Okay, so for an example, if I show you this arr equals to, then I put up, let's say, numbers 45, 88, 96, 30. Okay, so you can see that this is basically a list, right? But although this is a list, this is acting as an array. Why? Because list is nothing but an storage of multiple items. Okay, so we can see that 1, 2, 3, 4. four numbers are stored here, right? So if I do this print arr and print type arr, what I will see? I will see the list itself and I will see that the class is list. Okay. Now, what is a numpy array then? Okay. What is an array and what is a numpy array? So the array, as I said, is a collection of elements, and it's ordered, of course, because you know, right, that these are ordered. So if you want to search for something, let's say if I want to search for something arr and I want to check the, let's say, second index element, okay, I should be able to see that. So 0 1 2, second index element is 96, we are able to get that, right? So the array over here is acting as a storage of elements that is ordered. Now what is a numpy array? Numpy array is an array powered by the Numpy library. Understand this. Numpy array is an array that is powered by the Numpy library of Python. Okay. So what is the difference between a standard array and a Numpy array? There is no heavy differences, but what is proved over time and time again, that numpy arrays are much more memory efficient. If you want to let's say search through a numpy array, if you want to do some kind of operations with numpy array, it is going to consume a lot less memory than any other type of arrays. Okay, so numpy arrays are extremely memory efficient. Apart from that, it also has all the like pros of an standard array. Let me show this to you. So let's say I want to create a numpy array. Let's say nar. I'm just naming it, okay? And to create a numpy array, as you can see, we have to do np dot array. And let's say I want to put different numbers. I don't want to use the same numbers. Let's say I want to use 85, 11, 36, 45, something like that, right? And then if I print nr and print type nr, what happened here? Oh, sorry, this needs to be passed as in storage of elements light an array. Okay, now you can see that the class is numpy n dimensional array. Okay, nd n dimensional array. Now you can see all the elements of the array over here. Now what can we do with this array? We can do a multiple things. Okay, so let's say if I talk about print, we can see that it is also fetching us the indexed element, right? The second index element. So what does this prove? This proves that numpy arrays are also ordered like our standard array. Okay, so numpy arrays are ordered. One thing. Now second, if we do something like this, every single element that we have in array is going to be multiplied with the number that is given. So all the elements, if you want to perform some kind of calculation in all the elements that we have over here, that's also possible. Okay, now in numpy we can actually create predefined arrays. Okay, so let's say I will just name it as predefined arrays. Okay, now what are these things exactly? Well, we have functions like this. Let's say zeros. What is this basically? This is something that creates a numpy array completely filled with zeros. Okay, so let's say if I do this and sorry z1, okay, I'm just naming it like this, np dot zeros. Now here you see what I'll do. Oh, I think my mouse is creating. Okay, so here what I'll do this. I will just explain what is this. sorry. Okay, so you can see that we have three elements here. Okay, three elements. And what is this two? Two is nothing but a two-dimensional array. Okay, a two-dimensional array with three elements. Two-dimensional array with three elements. Okay, if we want to do this, see, let's say if I make it four, see, I'll have four elements and two dimensions. Okay, if I do three here, I will have a three-dimensional array. Okay, I hope this is clear, everyone. This is how a numpy array can be created with all the zeros. Now, that is not the only thing. If we want, we can do this with ones. Okay, same thing. NP ones, 3 and 5. Let's say I'm going to keep it till oh sorry, I also have to print it, so you can see that all created with one. Okay, we have four elements in a two-dimensional array. Now the next thing that we have is called full. What is full? Basically, full is something, let's say I'm gonna name it f1, and I am going to use, sometimes my mouse tend to give up. Anyways, it's working. Let's say 15. Okay, what this will do, this will simply create an array, but with what element? With 15. So full is a function that creates a numpy array with a constant value. For this is 15. Okay, I hope it's clear, everyone. Now let's talk about ranges in numpy array. Okay, so what do you mean by ranges? What do you mean by range? Range is simply a particular start and end point of, let's say, a group of elements within which all the residents stay, right? So now if we do this, let's say an array called n1, and I'm gonna be a range, sorry, a range. Okay, and within this I will provide a couple of arguments. What are the arguments? Let's say the starting point 5, the ending point 15. Okay, and if I print it n1, see, from 5 till 15, of course the last indexed element is not counted, is given, right? 5 to 14. Now let's say if I want to add let's say step within this. Okay, so how to do that? Let me do it with an example of this only. Let's say n2, but this time what I want 5 to 15, but I want, with a small catch, I want every second element. Now if I do this, you can see that 5, then 7, then 9, then 11, then 13. 15 as usual is not printed. Okay, so this is what a range is. It provides you with a range. Now this is something that you have seen before as well in different list elements and all, but there is another thing in NumPy called linspace. Okay, let me write it down. Linspace. What is linspace? Linspace is linear spacing. That simply means it is going to give you an array of multiple numbers, but the spacing between each of the element would be linear in nature. Okay, so let's say if I do this lnn linspace 1, okay, and I write this np, sorry, dot linspace. Now, sorry, yeah. Now let's say 10 to 20. Okay. If I do nothing, if I simply NLN1, if I simply print it, you can see that it is going to calculate a linear spacing all by themselves, and this is in a floating number. But let's say if I provide a space like this, let's say 2, it is going to create two elements with linear spacing. So 10 and 20, two elements in a linear spacing. Gap is 10, right? Now see the catch. If I make it 4, 10, 13.333, 16.666, and 20. Four elements with linear spacing. So from 10 to 13.333, it's 3.33. Again, from 13.33, 16.6667. Another gap of 3.33. Then again 16.6667 till 20. Another gap of 3.667. Right? So this is what linear spacing is. Generally, spacing between numbers does not fall into integer standpoints. That's why we can see that it is floating into sorry, it is landing into float numbers, right? But if we try out something like this, let's say I want to create an array, let's say from 1 to 10, and I want, let's say, 10 elements. In that case, these still are float numbers. See, 1 point, 2 point, these things are given. Okay, if I do something like this, d type equals to int. Okay, in that case, it is going to give you a float number. But if you do it here, it is going to give you a false input. So 10 to 13 we have 3 point, 13 to 16, then again 16 to 20, we can see that's phone numbers, right? So my suggestion would be, if you are not sure how the spacing is going to be, do not use this forcible integer conversion. Always keep it off. Okay, I hope it's clear all. Now let's talk about random arrays. Okay, now by default Numpy provides you with floating point numbers as an array element, okay, as you can see on the top. But there is a probability or a possibility for us to change it. Now, the very first thing that I want to show you is this. Let's say nrn1 random, okay, np dot random is the function name, okay, then rand random number, okay. Now let's say I'm gonna put up something like 2 and 3, okay, and I'm gonna print it like this, nrn1, okay. We can see that it's a 3 digit, I mean 3 element, two particular dimension array that is created based on this logic, and the numbers are absolutely random, okay. But let's say you want to create a random array of an integer elements. You can also do that. How to? We simply take it up, and we can see that here we have written rand, right? We will make it randint. Okay, we're gonna name it 2, and here you go. Narend 2, what happened? Oh, okay. uh, there is a small mistake here. So see how this is also a learning, right? So when you are using this random.rand, it is supposed to create an array of random numbers between 0 and 1, and this 2 and 3 is going to work as your dimensional matrix. Okay, so this 2 and 3 I'll just mention also here. It is going to work as your dimensional matrix in case of random.rand. But in this case, this works as a range. I'll just write it also, that works as a dimensional matrix. Here, this works as a range. Okay, so with range, what exactly happened? I am telling that create random integer number, and I have given them a range from 2 to 3. So only possible integer that they could find of is 2 only. Okay, that's why they have given this. Now if I make it 30, see, okay. Oh, it's right only, because by default, what happens? I did not provide any shape, right? That what kind of dimension I want for the random integer. So it is simply creating one integer out here. If I do it multiple times, you will see that it is going to generate multiple random numbers, random integer numbers. Okay. So if I want to put this into a shape, I also need to provide a shape, right? So I will simply put this up in a box. The first one is going to work as a range. Okay, so this one is going to work as a range. I'll just mention it here, that here 230 is working as a range, but here if I put this up, sorry, if I put this up 2 into 3, this is going to work as a dimensional matrix. Empty object is not called, oh sorry, multiple brackets, my bad. Yeah, I think this looks good. int object is not callable. Where am I calling the int object? Oh, okay. Then it's to be a comma in between. Sorry. All right. Now we can see that random elements. Okay, 9, 2, 6, 28, 26, 14, but all between 2 and 30. I'll also write it over here, that here 2 and 3 works as dimensional matrix. Okay. See, every time you run this, you are going to get a different set of numbers. Clear? Now, NumPy contributes of multiple mathematical functions that we can play around. Okay, so let's say I would like to create a couple of arrays. So let's say ARR 10 and ARR 11. Okay, two separate arrays I have created, and I will do np.array, and let's say I'm gonna put up some random numbers 4, 8, 9, 10, or maybe 15. Okay, same thing. I will do, let's say, 2, 6, 13, 17. Okay, two different numpy arrays are created. Now what can we do? We can perform mathematical functions in here. So let's say if I do this, print ARR 10 plus ARR 11, sorry, 1. I'll get the summation 4 plus 2 6, 8 plus 6 14, 9 13 22, 15 7 32. Okay, now if I do this, in here the gap is 2, 4 minus 2, 8 minus 2, In this case, it is going to be a negative integer. Why? Because I am subtracting the smaller number from the higher one. Okay, same thing here. Okay, now you can do multiplication. Let's say I have to do this. See, 4 into 2, 8 into 6, 9 into 13, 15 into 17. If you want, you can do division as well. See, you are going to get all the divisive elements in here. Okay, now apart from this, these are basic mathematical functions. We can do something else as well. Let's say I am creating an array. Let me name it AR12 np.array. Okay, now what I want to do, I want to do np dot square root of the ARR12 11429316 4, right? Natural logs of all these numbers. If you want to find out the exponential factors here, you can get them as well. Clear, everyone? There is another thing called reshape. Okay, sorry. What is reshape? Reshape is how exactly the dimensions are and how we can actually change it. So let's say there is a numpy array. Let's say ARR 13. I'm gonna name it. Okay, np dot a range 1 to 10. But if I simply print it ARR 13, I'm going to get an array like this, right? A one dimensional array. But let's say I want to reshape it, and I want to reshape it to is, let's say, okay, 3 rows, 3 columns, 3 3. See, it will become a reshaped array here. Okay, I have 3 element, 1 2 3 4 5 6 7 8 9. Last is not counted. Okay, here is a catch. What is the catch? The range and the reshape structure should align with each other. You cannot reshape an array with a structure if the numbers that are lying inside do not follow it. What do I mean by this? Let me give you an example. Let's say I want to reshape it with let's say 2 and 3. Cannot reshape array of size 9 into two shapes. We cannot. But what if I do this? Sorry, this will not also work. 2 into shape, right? So I think 1 to 7 will work. Yeah, right. So I can get 3 elements with 2 dimensions, 1 2 3 4 5 6. Again, if you want to do a 3 by 3, you cannot reshape. Okay, I hope it's clear, everyone, that why exactly the reshape is not behaving the way we want. Okay, so I'll just mark it as reshape wrong here, and I will keep this wrong logic here. Okay, and I'll make it right and keep it here. Clear, everyone, on the reshape? The next thing is statistical functions that you can actually do with numpy. Okay, so let's say I have an array. Let's take this array only. Okay, so 1 to 7. Yeah, let's take this array only. Now let's say I want to find out print np dot sum of an array. Okay, and what is my array name? arr313. arr13. What this will do, this will sum up all the numbers. 1 plus 2 3, 3 plus 3 6, 6 plus 4 10, and then 5 and 6 11, 10 and 11 21. Okay, this is going to give you the summation. Same way, if you want to do something else, let's say if you want to find out the average, it is going to give you the same. Let's say if you want to find out the standard deviation, it is going to give you the same. If you want to find out minimum and maximum, okay, if you want to find out the minimum and maximum, so let's say np dot mean I'll have over here. The same way we'll have np dot max. Okay, arr13. Okay, 1 and 6. 1 is the minimum element, 6 is the largest element. I hope it's clear to all of you. Now let's talk about dimensionality of numpy array. Okay, there are multiple dimensions in which we can actually create a numpy array. Generally, most of the data that comes our way for data analysis, for machine learning and all, are 2D data. There is a row, there is a column. If I'm talking about the structured part of the data, right? Unstructured data can be different, but generally all of our machine learning models, maximum of them, the traditional ones, gets fed by structured data only. There is row, there is column, but there are other types of data. We have 3 dimensions, we have 4 dimensions, and we are going to have a look that how exactly those different dimensionals data look. Okay, so let's say I'm just gonna name it ar2d. This is going to be a 2 dimensional data. Okay, so np dot array, see what I'm doing here. Okay, I'm creating the skeleton structure. So let's say 1 2 3 4 5 6. Let's keep it simple. Print, sorry, ar2d, and also we want to find out few more things. We want to find out its ndim. What is ndim? Ndim is number of dimension. We want to find out its shape. Okay, must be 2 or 3 tuples got 4 dot array 1 2 3 4. Oh, sorry, my bad. It's a 2 dimensional array, right? So yeah, it should be covered with another set of brackets. Yeah, now it will work. Okay, so number of dimension 2, shape 3 columns, I mean 3 rows, sorry, 2 rows and 3 columns we have. Okay, 2 by 3. Now we can do this for more than 2D arrays as well. So let's say I want to create something like this here, 3D. See how exactly I'm gonna create it. First of all, my array blocker, first dimension, second dimension, third dimension. So in this third dimension, we'll put up the numbers. Okay, Okay, we have it. Now, if we do the same thing here, instead I mention AR 3D, 3D, 3D. See, three-dimensional array shape is basically your one block, two rows, and three columns. Okay, so see, a dimension gets added. So this block dimension is getting added over here, right? Now, if I talk about 4D array, let's make it more interesting. Be sure that this 3D and 4D data will never come along your way, but this is something good to know thing, right? It's always okay to learn. So we are not gonna scratch our heads off. I will simply use the np.once and I'll mention here how we can create it. So two groups, three blocks, four rows, five columns. Okay. And let's say I want to make t type int. Otherwise, the number will float around. Okay, I don't want that. Now, if I copy this, you can see how exactly the data got printed. We have four dimension, two group, three blocks, four rows, five columns. Okay, so here you can see that how exactly the 4D data looks like. Okay, I hope it's clear, everyone. Now, with Numpy also, you can do your slicing and indexing and everything, the things that you could have done with other data types that we have gone through so far. Okay, so for an example, let's say here are 15 or something. I'm just gonna name it. Okay, I want to, let's say, see, indexing is something that I have already shown you, but just for the sake of it, getting the second element looks something like this. Okay, this is your indexing. Now, if you want to slice it up, okay, let's say I want to get from 1 to third element. Okay, first index, second, third. Obviously, the last one is not counted, so we get 29. If you make it 4, then we'll get the 39. Okay, then if we want to reverse it, we have also gone through that during the list, but anyways, we can start off something like this. So this is the entire thing. I want to start from the last one. So see, the entire array is going to get reversed. Clear, everyone? All right, so this covers the basic parts of NumPy. All right, so here we have covered the basic part and certain intermediate section of NumPy. Now, there would be a sequence to this. We'll have a chapter 2, or let's say part 2 of the video, where we will be covering more advanced topic of Python, vectorizations and all. Okay, so stick around, and I'm quite sure that if you have gone through the first part, that is going to be uploaded soon. I mean, obviously, if you are seeing this, it's already uploaded, my bad. And the next part is also going to come soon. So if you combine these two, I think your Python NumPy is going to be completely clear. Okay. Thank you for watching. And yeah, what can I say? I am coming back after a long time. So yeah, please keep showing your love, subscribe, comment, and yeah, like of course. Thank you. I'll see you in the next video.